Hi there, I welcome you to my channel, The Chemist Chemistry. We are still on the topic electron configuration, and in today's video lesson, we are going to talk about the electron configuration of the chlorine atom as the main objective for today's lesson. Before we start with the electron configuration itself, I'd like you to know that chlorine is the 17th element on the periodic table. In other words, it is having an atomic number 17. And we've learned that in a neutral atom, the number of electrons is equal to the number of protons, which is equal to the atomic number. So it means that in the neutral atom of chlorine, we have 17 electrons and 17 protons respectively. Now, here we have 35.453, indicating the atomic mass of the chlorine atom. Then we have Cl, which is the chemical symbol for the atom chlorine or the element chlorine. Then we have the neon electron configuration, that's the neon core electron configuration of the chlorine atom. So let's move on to the board in order to demonstrate how we write the electron configuration of chlorine, obeying the rules governing the electron configuration, that is the off-Bohr's principle, the Pauli's exclusion principle, and the Hans rule of maximum multiplicity. Okay, so the electron configuration of chlorine as a chlorine atom. All right, so we have already learned that from the first slide. We learned that chlorine is having 17 electrons because it is the 17th element on the periodic table and it is a neutral atom. So to write the electron configuration for the chlorine atom, you first write the chemical symbol Cl, and then you write the atomic number on your left subscript. Then you bring your equal to sign. So according to Bohr's principle, we learned that the first orbital is the 1s, right? Very good. And it can take a maximum of 2 electrons. From the 1s, we move to the 2s, which will also take a maximum of 2. From the 2s, we move to the 2p, and the 2p orbital is degenerate, meaning it's have subshells. Each subshell take a maximum of 2 electrons, so total making 6 electrons. All right. Then from the 2p, we move on to the 3s orbital. And from the 3s also take 2. From the 3s, we move on to the 3p, which also take a maximum of 6 electrons. All right, so looking at this, we can all see that we have 2, 2, 6 making 10, another 2 here making 12. So when this also take 6 making 18, so in all it is more than what chlorine is supposed to take. Do you get a point? Yes. So it means this chlorine 3p orbital cannot take 6 electrons, but rather 5. Why? Because it is having only 17 electrons. So we have 2 here, 2 making 4, another 6, 10, 2 making 12, and then so if here is 6, it means it is the 18th element, which is argon. So we have to subtract 1 from this to make it 5. Then that will be the correct electron configuration for the chlorine atom. So we erase it and we write 5. All right, so now we have 17 electrons being distributed in the various orbitals of the chlorine atom. Now, this is the condensed electron configuration of the chlorine atom. Let's see how the expanded configuration of the chlorine atom will be using the Bose notation and then the other expanded form to illustrate it. All right, so let's proceed. So we have 1s, 2, 2s2, we have 2p. Don't forget the 2p is degenerate, so we have 2px, 2py, 2pz, right? So we have 2 here, 2 here, and 2 there. Then from there we move on to the 3x, making 2. And the 3p2 is degenerate, so we have 3px, taking 2. We have 3py, which will also take 2. And then we have the 3pz, which will take 1. So this is the correct electron configuration of the chlorine ion. This is the expanded configuration. Now let's use the Bose notation as well. For the Bose notation, you have the 1x, then you draw a box under. You have the 2x, draw a box. You have the 2px, the 2py, the 2pz. Okay, z, 2pz, 2pz. They are degenerate, so draw the box together. You have 1, 2, right? Yes. Then from here, okay, so we have the 3x, right? Okay. Then we have the 3px, okay? We have the 3py and the 3pz. Also degenerate, don't forget, from quantity numbers, we learned that the p, the d, and the f orbitals are degenerate. I have that video lesson link below this one. You can watch it to enrich your understanding about quantum numbers. Okay, so here the 1s will take 2 electrons. They must be in an opposite direction, right? Yes, each orbital can accommodate a maximum of 2 electrons, and the spin must be in an opposite direction according to Pauli's exclusive principle. We learned that already, and I have the video link below this, so you can watch it to enrich your understanding. Don't forget, one electron must spin up and the other must spin down according to spin quantum numbers. The video link is below. Okay, so here 1, 2, 1, 1. They are degenerate, so parallel first before pairing begin in the opposite direction. 1, 1, 1. So it's fully filled. Up, down. Okay, all right. Okay, 1, 1, 1. Right. So this is 15 already. 11, 2. So 16, 17. So this is how the electron configuration of the chlorine atom will be. Yes, using the condensed, the expanded, or the Bose notation. So we will end here, but before that, there are other properties of the chlorine atom that I want us to take note of before we end the lesson. So let's proceed to that slide. Okay, so we have the chlorine here, the atom. As I said earlier, this is a chemical symbol Cl, the atomic number being 17. So we have an atomic number which is the same as the proton number, and in the neutral atom it is equal to the number of electrons. Okay, then we have the symbol Cl. We have the electron configuration. This is the neon core configuration, and the name is chlorine. We have the atomic weight, the relative atomic mass. Okay, we have the acid base property of chlorine of higher valence oxide. So specifically, chlorine is strongly acidic. Take note of that. And in terms of its crystal structure, chlorine is orthorhombic. I want you to take note of that. That's the crystal structure. The structure of chlorine is orthorhombic, and then it is part of the halogen, that is the group 7. Yes, so their family name is halogen. So take note of that. And then the physical state of chlorine at 20, its physical state at 20 degrees Celsius or 68 Fahrenheit is gas. So at this particular temperature, chlorine is or exists as gas. You kindly take note of that. Now, before I end the lesson, let me explain this neon core configuration of chlorine. Now, when we talk about the neon core configuration, the neon, the moment you hear the word core, it means you're talking about the inner part of the element or the atom in question. So neon core meaning that the neon is the 10th element on the periodic table. So meaning the neon will occupy the inner electrons of chlorine. You get the point? Then you write only the valence electron configuration of chlorine without bringing the inner configuration of chlorine. So you just write an element with atomic number 10, which is neon there, and then so meaning that has covered the core or the inner electron configuration. Then we write only the valence electron configuration. So let's go back to the blackboard and then demonstrate that before we end this video lesson. Okay, so using the neon core, we know that neon is the 10th element on the periodic table. So the configuration of neon will start from the 1s and end on the 2pz or the 2p orbital for short. You get a point? Yeah, so if you are using the neon core, just a matter of opening a bracket like this, and we write neon chemical symbol inside, then we close it. Okay, then so it means that it has covered from the 1s to the 2p. So that is the core electrons. Then left with the valence electron, which is the third shell. Okay, yes, that is the valence shell. We have the 3s up to the 3p. Okay, specifically the 3px, 3py, and the 3pz. So we start from the 3s, which is not part of the inner electron. So 3s, and it took only 2 electrons, right? And we know that the the 3p also took 5 electrons. You can see that from where the 3s took only 2, and then the 3p took only 5. So we indicate that also there, 3p5. So this is the configuration of chlorine using the neon core, and it is accepted. Kindly let's take note of that also. Yes, so we will end here and continue with the electron configuration of the chlorine ion, which is the chloride ion. Okay, so take note of that. Stay tuned. Don't forget to subscribe to the channel, like the video, and tell me your mind in the comment section. Bye.